quick announcements before we get started with Rick's presentation. Lunch will start at a little bit after 12 o'clock. It's a buffet lunch. There are a couple of reserved tables for our guest speakers, but other than that, the tables are free and clear, so find a seat. Next door, next two rooms here down the hall, and the other manatee rooms. We've got the entire upstairs, so you go into a room and it's something that NARCON is doing. So the luncheon and the banquet are both next door. Remember, it's time to go buy and visit from the vendors. After you get done here, we got some great vendors. Go over there and buy some product, take some stuff home with you. Want to spend, we appreciate them being here, and we'd love to have you send them home with lots of cash and credit card charges. So thank you for that support. Also out at the registration desk, we got plenty of t-shirts, $10, patches are $4. Will become collector's items because we only have about 50 or so left, and everybody will want one. $4 for a patch, can't beat that. Made in China. And check for the raffle prizes. On top of the piano, we've got the board there that shows the raffle prizes. We're picking them out during each session and posting the numbers up there. So find your number, then go over to the registration desk, and they'll give you your prize. So, in for this session, we have the esteemed Rick Boyette, otherwise known as Rocket Rick. I've known Rick since probably the late 70s. A friend of mine, I'm proud to call him my friend. He's one of the more knowledgeable rocketeers, all the way from low power and competition all the way up to level 3. He does some very interesting projects. He's always been known as an eclectic builder. He generally doesn't build things that are boring or like everybody else. So you can learn some interesting things here today. He was the president of the Florida Spacemodeling Association down in West Palm Beach. He ran the Winter Nationals, the Gator Nationals down there for several years, and that was one of the biggest high-power launches in the Southeast, if not the United States. And Rick carried that off with aplomb for many years, and still has the scars to prove it. He's on the Level 3 certification committee for the NAR, and his interests, which you'll hear about today, include scale modeling, scratch building, plastic model conversion, and I've got the scars to prove some of those as well.
Sorry!
NAR competition, technical writing, and Rick, we're glad you're here, so please join me in welcoming Rick Boyette.
Oh, thank you all. Thank you very much. As Pat said, I've been flying for longer than I care to admit. Picture over here, this was in Banke, Florida, not far from here, last November. That was my Level 3 certification project back in 98, maybe. And that's a 12-to-1 upscale of the Estes Alpha. It's flown several times on M motors, and I do have a video of it on my laptop. I don't know if we'll have a chance to look at that, but anyway, that is kind of a typical Level 3 type project. We're going over a lot of things today, but the main thing I'm going to be focusing on is getting your high power cert. So I want to ask first, who here is Level 2 cert? Okay, quite a few about Level 1. And who here has no high power certification at all? But you want to get it, right? All right. Okay, well, I'm going to talk about some techniques and methods to do a Level 1, 2, and 3 project. I'm going to briefly go over like a level 1. I had an outline on here, which I'm totally not going to follow. But let's see here. Yeah, that's my outline. Look at it quick because I'm going to skip past it. If you guys want anything, just email me, and I will be more than happy to unload all kinds of stuff. More than you probably ever wanted to know about these things. But anyway, let's start off with like a Level 1 project. So this, I call this the white trash because I built it out of trash, and it's white. So, but this is a typical, what you would call a Level 1 rocket. It has up to a 38 millimeter motor mount, but it can also, step it down to a 29. Typical H motor. Like an H180 will run you around, for the hardware, be about $60, and then the reload, maybe 20, 25, something like that. I don't know, I haven't bought a motor in years. I have so much of it laying around that I tend to fly old motors that do interesting things. This rocket is equipped with an altimeter bay, and I will pass it around so you guys can touch and feel it. And it's got a little rotary switch to arm and disarm the electronics. And what this does, we call dual deployment. Most of you probably heard of that, but you can either use the motor ejection. For level 1, you don't have to use electronics. But if you want to get serious with it, it's probably a good idea to start practicing at that level. And you use a motor ejection to blow this part out. And then if you have an altimeter in it, you can just blow a small drogue chute or a streamer, and then at 500 feet or whatever, you can pop this front part, which I have screwed on so I can't pull it apart. But it'll blow a main chute out. So the advantage is you don't have to chase your rocket all over the county to get it back. And Palm Beach County is very big, so I've been known to fly things a long distance. So I'll go ahead and pass this around. It would probably cost, if you bought a kit, it's probably about $50, $60. But you can scratch build and get the tubes. I get stuff out of the junk pile, so anyway, I'll just pass that around and you can kind of get a feel for what a level 1 typical project would be. And you can build that in an afternoon, so it's not like it's real intense. Especially if you're getting a cert, you want to kind of keep it simple, but make it robust. The fins are through the wall, they're glued to the motor mount, so all the loads transfer to the airframe. You don't snap the fins off when it lands. That's usually what happens if you just surface mount fins. They might hold up fine under boost. If they don't, it's also cool, but...
Rick, you may want to add that in general for an AR certification is that the requirement for passing is that the rocket has to be capable of immediate reflight after it lands.
That's correct.
You don't have to immediately refly it, but in the judgment of the certifying person, it has to be capable of reflight.
Yeah, without repair. So if you can have like a little bit of a zipper maybe, or slight crack or chip of a fin, but if you've broken a fin off or you've separate, and it also has to fly the way you intended. If you say I'm bringing it down in one piece and it comes apart, it might be safe, but that wasn't what you said you were going to do, then you're back to square one. So what else we got? Okay, level 2, go Bucks. Someone asked me how old this rocket is, and it's been rebuilt a few times. Part of it, I flew this at the Winter Nats in Florida, and part of it landed in a rice paddy, and I never found it, and so I've rebuilt part of it. But I'm not going to pass this around because it's a little on the heavy side. But I will try not to take the ceiling out. You can see it has a much larger motor mount. It's what we call a 54 millimeter mount. This will get you into for a level 2, you have to have a J motor. And again, you do not, as far as I know, you don't have to use electronics for level 2 cert. But it's highly advisable to do so, because when you get the bigger motors, the motor ejection chargers aren't necessarily as reliable as you might like. So it's good to at least have it as a backup. You can either use a timer. I want to take the ceiling out for the day's over, man.
The other suggestion is, Rick, too, is that you can use 38 millimeter like the J350s.
Yes.
So you don't have to have a 54 mount.
Yeah, but if you're going to build a level 2 rocket, you should build it to where you can do a little, you don't want to limit yourself. It's always easy to step a motor down. So you can put a 54 or 75 mount in it, and you can always fly it with an adapter. And this same thing, it has an altimeter bay, and it comes apart. And no parachute in this one. It's in the other one. But I want to talk mainly about altimeter bays and some construction. So that's kind of, basically it's just an upscale version of that rocket. This is 4-inch diameter. This was a kit, PML kit, that I've done a little reworking on. This is the Endeavor. This was called quantum tubing, part of it was, and the rest of it was just a fiberglass, which I want to talk about how to beef up these paper tubes cheaply and easily. So anyway, that's a typical level 2 rocket. Will run you maybe $100 to build it, and to fly, same thing, the casings might cost you $70, $80 for a reload casing. Most of the high power motors are reloadable. They do make single use motors, but if you're going to be in this, you should probably get the reload. Nice thing about being with a club, you can borrow motors and parachutes and things and save some money that way. So. And then we got a level 3. This is part of a level 3 rocket. The beefy part. This is a pig. This was a guy's level 3 project. And it's not as big a pig as my Alpha, but it's still a pig. And it's got slab fins. They are solid fins. I like to go with built-up fins on the larger rockets. And again, I'm not going to pass this around, but you can see it's got a lot of heft to it. A rocket this size might weigh 40 pounds to 80 pounds, depending upon how inefficient you are. And I'll show it. Here's a typical altimeter. You definitely have to use electronics for level 3. And you can't just build a rocket, show up at a field, and say, hey, I want to get my level 3 cert. Oh, no. Why don't you come over here, Steve? He's also on the level 3 cert committee, right?
Yes.
Okay. Yeah. Chop, chop. He and I have been flying together off and on for how many years? Again, we don't want to say
More
that.
than I want to count.
Yeah.
I've got more grade. That's the problem.
Yeah, yeah. So, and he and I are on the level 3 cert committee. So what you do is, you, if you want to get your level 3, you have to approach one of us and say, to the committee and say, I want to fly a level 3 project. Will you be willing to be my L3CC member, or if you're in AAA, a TAP member, to review my project? So what we do is we have you prepare a proposal for what you want to build, and then we review it and talk about it and say, you know, hey, you might want to consider using this. We're not going to tell you how to build it, but we want you to understand that, yes, there are people looking over what you're doing, and we're going to be very particular, because once you get level 3 certification, that's an M motor, and this, I believe, is either a full L or an M casing. But there's a lot of energy in one of these motors, and we don't want people just going out there and being able to fly this stuff without having some kind of showing minimal competency. So if people come to say, oh, can I fly this oddball rocket, you know, a big giant Sputnik thing? Like, no, we want you to damn it. I'm kind of at fault for that, because that alpha that you saw, that's actually the bottom half of that was my original level 3 cert, and it was a 2-stage rocket. And now I'm the reason why they don't allow complex rockets. I have a very interesting video of that flight, and I have to put that on. No, I better not put that online.
Our webpage there's a checklist involved for what we're looking for when you submit your proposal for it. There's basically 3 sign-offs. In advance of your flight day, we're going to look at how you built your rocket, your structure. We're going to either inspect your rocket physically if you happen to be nearby. We have about, 35 members now?
Something like that. We got quite a few.
Yeah, and we're pretty much spread all over the country. So if you're anticipating a project, get a hold of an L3CC from the get-go. And he'll talk to you about your project, your basic design. When you get more official on it, you're going to show him pictures, or he'll come over and look at how you're building it to make sure you're using good building techniques and it's strong enough. The other thing he's going to look at is how you're designing your recovery. As Rick mentioned, the electronics are required. Actually, it has to be dual redundant electronics.
That means you need more than one.
Yep. And if you're doing something a little bit crazy, I mean, again, we have some folks within the LPCC who are more specialized in high performance, some different build techniques and the like. So if you're doing something we're not comfortable with, we have our own LPCC forum, and we're going to talk about you behind your back.
Yes, we are. I'm going to pass around some altimeter, and two of them are altimeters, and one of them is an altitude apogee detector, which is basically an altimeter, but doesn't tell you how high it went. All it does is fire an ejection charge at apogee, but it's barometric. There's 2 types of altimeters. There's a accelerometer type, and then there's the barometric type. Some of them are only single deploy. Some of them are going to have more than one event. You can fiddle with them, program them. Some of them actually you can download to your computer, see what your rocket actually did. But
my only advice, and I'm going to get off the stage here, is if you're going to do certification of any kind, KISS principle applies.
Absolutely. Keep it simple. Schmuck.
Keep it reliable. And remember, you got to get it back. You may want to fly 15,000 feet. If you can't bring the rocket back for the person certifying you to inspect it, no good. So,
yeah.
That's the most important thing.
Yes, sir.
There's a couple of example level 3 documentation documents up on the website, so if you want to get an idea of what's involved.
Right. Yeah. You do have to submit. You don't have to go crazy. I may have a guy submit dissertation like, dude, you're not going to the moon, okay? Just. But that's good, because it shows that, hey, I'm into it. Okay, we want strike a balance, but have pity on us, because we don't want to spend hours and hours reviewing it. Yes, sir.
Is there a written test associated with that?
No.
Not with level 3.
Level 2 has a written. I'm glad you mentioned that, because level 2 you do have to take a written test that basically covers some basic information on how to behave.
Most do your level 1, get some experience with your level 1 flights, go do your level 2, get some experience with your level 2 flights, and then come talk about level 3.
Yeah, because it is a long process, and you got to keep in mind that when we're reviewing them, we're taking our time to do it. So we don't want somebody just with that kind of interest. Oh, I'm going to get my level 3 so I can brag, and I'm never going to do it again. Well, now you've just kind of wasted more time because you're not serious about it.
Yeah.
So most of the time, if you go through the trouble to get a level 2 exam, you have a successful level 2 flight. Yes, technically you might be ready for a level 3, but you got to remember there's an order of magnitude difference in motor power between a J motor and an M motor. So it's not like it's just a little bit bigger. It's a lot bigger. It's 8 to 10 times more power, more mass going off the pad. So it's serious stuff. And you can, every high power launch I've ever been to, I've seen flights that I'm like, what the hell is that guy doing? Why did he do that? Did anybody check that? No, because it's heat of the moment. You got a lot of people trying to get out of the pads, get their rockets up on the pad, and then somebody forgot to hook their parachute up, or somebody didn't put their motor in properly, and then comes straight. And these things could kill somebody. Let's be real about it. These things do have a lot of potential. So that's where we lose sleep, is people thinking casually, like, yeah, no big deal. I'll go ahead and fly my rocket. No, not on our watch. So.
My professional roots are going to show here, but checklist, checklist, checklist.
Absolutely. Yeah. The better organized your presentation is, obviously, that reflects well on you as a person and as a rocketeer, and we're going to take a much better view of that than someone just sketches something up by hand. Oh, here's what I want to do for level 3. It's like, no, I don't think so. Okay, enough of that. Talk a little bit about like altimeter bays. I do have it up here. It's going to be terribly visible. I'll try to zoom in a little. You can get a better idea of what an altimeter bay looks like. But okay, and typical altimeter bay, like on that rocket that's going around, it's inside a coupler. And you've got an all-thread rod or a bolt or some means of connecting a plate that you can remove. And you kind of want to think it through, because you have to be able to put whatever your electronic device is. You don't want to make it a ½ inch too small and your altimeter doesn't fit. And I've done that, so hello. But you want to make it big enough that you can work with it. And that's what's good about doing it at level 1. That way, you can still use your motor ejection without any problem and get some experience with these altimeters. And they're fairly inexpensive now. They used to be really pricey, but you can get a nice altimeter for what, $35, $40 online, up to $60, $70 for the fancier ones. But there's no reason not to get an altimeter and learn how to use it. They're a lot more reliable now than they used to be. So we used to have issues with them not working like they should, but nowadays you can get a pretty good quality piece of equipment for a reasonable price. If you're going to get into level 2 and above rocketry, you're going to be spending money anyway, so you may as well spend money on something that's going to do you well. So and basically, you can make them 2 different ways. You can either permanently affix it in the rocket, or you can make it a little simpler, or a little more complicated, where you can remove it from the rocket. I'll see if I can scroll down to that. Here's a typical setup of an altimeter. Oops. So this is what we call a redundant system. It has two altimeters in it, or devices. It could be a timer, it could be an altitude deployment, it could be an accelerometer, but there's basically, especially when you get to level 3, you do have to have a redundant device. So this was that's one unit, that's the other unit. You have to be able to arm it and disarm it, safe it out completely on the pad. You don't want to be carrying this thing fully armed, walking down the flight line, a little gust of wind comes off, pow, off it goes. I mean, I don't know about you guys, but I've been to launches where people have these things go off inadvertently, and it's a little disconcerting, to say the least.
RSOs will look at you very unfavorably if you check in a bird that is armed.
Especially with the igniter hanging out of the back of the motor.
Yes.
Well, it's common sense. You don't want to endanger anybody. And I know at LD or at a Triple E launch, they had a recent incident where somebody got hurt. Something went off on the pad. Somebody actually had severe burns, had to be airlifted to a hospital. And I didn't know the details of it, but it's amazing how quickly things can go bad.
Just one part of it are the details of that accident. It was safe going out to the pad. Keep in mind that not only do you have to know how to arm the rocket, you have to know how to safely disarm the rocket, and that was where they got in trouble on that accident. They were disarming the rocket, and they did not disarm it properly.
I think for level 3, we have to be able to safe out the charges as well as the altimeter itself, or have we gone away from that?
We've gone away from that. Again, there's still some, among ourselves, we still have some
Yeah,
questions.
man, we don't want to like dumb it down to the point where you don't have to think, but again, it's mainly safety driven. But the more shunts you add, the more switches you add, the more chance you have something to go wrong. That's where we get back to the KISS principle. So yeah, this one has you've got a shunt for the apogee for this. It's got 2 charges, an apogee charge and a main charge. The apogee charge is the small drogue that brings it down from whatever altitude up to, you can then have a main charge come out at 500 to 1,000 feet. So you actually have like 4 charges on this rocket, 2 per altimeter. So that's more stuff you got to hook up. But again, it's an all-day project. If you ever done a level 2 cert, you know what I'm talking about. You end up spending all day sweating bullets. Level 3 is even worse. Have fun, man. I had to grab one guy by his shoulder and look at me and I said, dude, take a breath. Breathe, it's fun. You're here to have fun. And I'm like, oh, you're right. And he crashed it anyway, but he was successful on his next try, so that worked out. He stuck with it. That's the other thing. If at first you don't succeed, hey, you learn. I learn every time I fly something. I'm sure everybody does too. And you look back and say, why did I do that? I knew better. So, anyway, and altimeter bays are fairly simple, but again, you have to think it through. Some rocket kits do have altimeter bays, so you don't have to design it from scratch, but let's beat that subject to death. So, if you get to that point, you're going to be having to build these types of components. So let's see the next page. Yeah, you can't really see it too well, but again, this is just a little schematic showing what a typical system would look like. There we go. So up here you have the nose cone. That pops off. Shear pins, that's important. A lot of times you've got a main in your upper compartment, and just the force of deployment will pop that nose cone off, and you'll see the main come out nice and billowy up there. And if that's your level 3 flight, that's a DQ, to use the NAR term, because you didn't design it to deploy at apogee. You wanted that main to come out at 500 feet, and if it deploys inadvertently, not only do you run the risk of losing your rocket, because it might be up 10,000 feet in the jet stream up there. You'd be surprised how strong winds aloft can be. It may not be that breezy on the ground. You get up above a couple thousand feet, and it picks up pretty quick. So you got the shear pins, and what those do is they're designed to be able to withstand that opening jolt, but the ejection charge is strong enough to shear them off. So it could be like a little styrene rod, like from a plastic model kit, those little styrene trees, those work great. And they're free if you got plastic models. You can make a bunch of those.
256 nylon screws are common.
Yeah.
The other part is use a minimum of 2. You don't want to use 1 because you don't want the nose cone cocking as it's trying to shear the pin.
Yeah, you want to spread your load. I usually use at least 4, or 3 or 4. So. And I've seen shear pins shear off, even though they weren't supposed to do it. So again, more is better. And then you got main parachute. That's your forward body tube. Holes for this type of removable altimeter bay. You got holes that are, you put like epoxy, a little nut on the inside of your tube so you can thread a screw through it. So that's all that is. Those are your nut. And then you just slide that down and you put a screw through it. That's what's at least two screws, typically 4. And then this is center the spacer tube. So when you put the altimeter, it's got a little ring between the upper and the lower tube, so you can actually remove the entire thing from either end of the rocket and just hold it in place. And then arming switch, the main charge would be up here to blow the parachute out. The drogue charge, you can run it down there in the bottom so it pushes everything out. That's the way I like to do it. Some people put their drogue charges up here, so just to blow the top off and then it pulls the parachute out. Me, I like to push everything out. Then again, you can cook your parachute, so you got to make sure you use a lot of wadding on that. Another thing I like to point out is what we call a forged eye bolt. You can see eye bolts, if you buy one at a hardware store, they tend to be just bent rod. And anything that's bent can be unbent. But if you go to the marine store, they'll have these forged eye bolts that are a lot sturdier, or an eye nut. An eye nut is threads onto an all-thread rod. And those are the best thing to use. Then, yeah, then you got it's got a fixed bulkhead in the front and a fixed bulkhead with a cutout in it in the back, and then a removable plate so you can access your charges and your altimeter device, pull it in and out. Then you have usually you put the altimeter on a sled and it has a little tube and you can slide it down on your rods there. So it's again, these are standardized designs. You can find references to this online. And that's pretty much it for an altimeter bag. Any questions on altimeter bays? Yes, sir.
I read about a forum about problems with RF interference between some of the altimeters and like Garmin Astro GPSs and other RF tracking systems.
There can be some, I'm not real familiar with it.
You can speak to it
Yes.
there, since doing it professionally also. Some of the things you want to do to minimize RF interference is try to use twisted pair for your wires. So that's probably the most important thing you can do to minimize coupling. Otherwise, you've got antennas sitting out there. Shielding. Again, don't try to run antennas from your transmitters right next to your electronics. So those are some of the things to do.
Yeah, I mean, we have to do some research on it to see what
Yeah, I
sensitivities
tested
are.
by Garmin Astro. I was doing a lot of reading on it, and the only one that really said that it had zero problems was the Perfect Flight SL100s, and I've tested mine with literally almost touching the altimeter with zero problems, but you do want to mention it as
Yeah,
an issue.
yeah, and I don't have any first-hand knowledge of the GPS units. Several people in our club have used them to good effect, and but you know, it's nice to be able to. If yours is drifting away, it is nice to be able to track it. I'll say that for it. You know, trackers are always a good thing if you wanted to go that route. Put tracking devices in. All right, built-up fin construction. For high-power rockets, built-up fins do offer several advantages over a usual slab of plywood like this one has here. One thing, it's a lot lighter. You can build up a nice cross-section and tape, you know, you can design an actual fin rather than just putting a chunk of wood on your rocket and calling it a fin. And so if you have lighter weight, then your center of gravity is more favorable. So you're not putting a huge bunch of tail weight. Now you got to add nose weight. It's kind of like I said, that's to me is kind of inefficient. So you want to consider doing it that way. You can make it a lot easier. I don't know how many of you have tried to put a beveled edge on some of this plywood, but unless you got a heavy-duty belt sander, it's kind of a chore. And you know, it's not that hard to make built-up fins. I'm going to pass this remains of a Nike something or other I built a long time ago.
Oh gosh, I remember that.
Oh, okay, shut up. It's a little tattered, but you can at least get an appreciation. This is very simple. It's built up out of plywood skin, and it's got a core rib that goes all the way through and epoxies onto the motor mount. And that's the way the real rockets tend to be built. You know, they'll have some kind of a hollow core fin, and it's so I'll kind of zoom in on that so you can see more what I'm talking about. So yeah, this is it's most real sounding rockets use some sort of a stretch skin hollow core fin. It's kind of more representative of what the real world is. We like to call ourselves rocket scientists, so there you go. So here's kind of a cross section sketch of it. You got a forward bulkhead for your motor mount. That's your motor mount tube. You got your fore and aft, and you want a solid tab that you epoxy not only to the motor mount tube, but also locks into the bulkheads. That way you transfer all your loads to this airframe. And have a rib. This would be a center piece in the middle, like a piece of plywood. And you can cut lightning holes in that if you want to make it even lighter. And then these ribs would be glued to that. This is like an edge view. And then this is your skin. So you can make them out of basswood, you can make them out of thin aircraft plywood, any number of materials. I've built them out of styrene, G10, fiberglass. G10 is very heavy. I see people like to put G10 fins on their rockets. And not only are they heavy, they're lethal. I mean, those things. And they flutter too. I like, come on, you want to build something up. That's the other thing you want to get rid of is flutter. Flutter's not the best understood phenomenon. I know a lot of people have done research on it, and it's just so how thick do I make my fin so it doesn't flutter? Well, thick enough so it doesn't flutter. I don't know. That's about how fast it's going, and especially if you get up close to Mach speed, you're going to have serious issues with that. So you want to, yes.
On the the motor mount. A lot of the L3 projects I've seen have like 4 all-thread rods running from bulkhead to bulkhead. What's that all about?
They don't know what they're doing.
I'll accept that.
I mean, the only time I would do that is if I'm going to anchor my recovery system. And that's another thing I see people, they put all this hardware in there, and then they got their shock guard anchored with some flimsy little thing up at the, like a little non-forged eye bolt that they just screw into that bulkhead. Well, that's okay for a smaller rocket, but you're not going to do that on this. You want to, I would put an all-thread rod through here with a nut and another nut all the way down, and then put that forged eye bolt or eye nut on there. And that transfers all that load. Your fin's now helping your recovery system pick up that load. But if you just have a little, this is like a little thin diaphragm there, and you can snap that right off if you have a strong force opening it. So those are things to keep in mind. How is load transferring, not only under boost, but during recovery?
Recovery is an uncontrolled event. Think about it, you have a 40-pound rocket there. Even if you've only got 10 Gs on various compounds, you're resisting 400 pounds there. Do you want to hang 400 pounds from a quarter-inch
eyebolt that you picked up at Home Depot for 95 cents?
Yeah.
Yeah, and the forged units are going to cost more, but you don't want that to fail. That's silly. So anyway, that's just a quick overview of what a built-up fin would be like and what it would entail. It's not that much more difficult to build one, and like I said, you can make a nice tapered cross-section. So you want to avoid flutter, you want your thickest section up at the fin root, and then you taper down to a thinner section at the end, because that's where your strongest bending force is at the joint. So that's why they built them that way. And I guess the wedge shape is more for supersonic flight, but it still looks cool. So.
How are you attaching the plywood skin to the core?
If it's wood, I just use either epoxy, that's a good quality epoxy, or some super glue with some wood glue in there. The main thing is you want to make a good contact. You can actually use contact cement in some areas. It depends on how you're doing it, but I've used wood glue, aliphatic resin type glue. Some epoxies don't stick well to wood, so you have to be careful with how you're doing it.
Wood glue is stronger than wood.
Yeah.
Any questions on built-up fins before I move right along? Anybody here use built-up fins? Just out of curiosity, you guys? Good. Preaching to the choir. Yes.
I do have a question about putting foam in between your centering rings. Is that standard, or is that just something that's...
You mean like great stuff, the expanding foam?
Yeah. I mean, I've heard it suggested on something.
What that does is it stiffens up that tube so everything's tight and it locks everything in. There's nothing wrong with using it. Just make sure you put a hole so that the excess can squirt out. Otherwise,
Personally, I think it's a waste of time.
Yeah.
Because you've got double tubes here, you're already way stiff down there.
Yeah.
So I personally think it's a waste of time.
I've never used it. That stuff's kind of...
That's a lot of challenge.
Yeah. Now, I've done it on nose cones that are real thin. It works. It's a good way to stiffen up a nose cone, but depending upon who built the nose cone and what it was made out of. All right. Let's see what next we got here. I had built, like Pat had said, I've actually built smaller versions, and I've used the same method. This is an X7, Lockheed X7 scale model that I built for NARCON, which I meant to bring, and I forgot it because I was bringing too much crap already. But it was an interesting project, and it was built up basically. Okay, yeah, these are the thin. I think this was 1/32 plywood, and that's the rudder, the booster things there, and then so these are the skins. That's just styrene, and that's the rudder. So that's basically the booster components, and you can kind of see the other parts off to the side there. And here's what it looked like when it was put together. This is just, you can see the wedge shape on the airfoil there, and that's just styrene. It's super glued onto a wood rib. So it's, it was pretty easy to do it actually. That was the easy part. I'm not going to go into what the hard part was. And I did fly it. That's what I looked like it was finished. And it flew up great, but I had some issues, and it kind of Didn't have such a good landing, but it's kind of a cool model. Actually, I want to build a bigger one. This one's only like this long. It's a BT-50 booster tube on there. So. But the nice thing about it, especially for scale, you know, to do these scale cross sections, that's about the only way you're going to be able to do it, unless you want to spend like the old FSI Black Brant. Remember those with the 1/4-inch slab of balsa, and it's just cut away everything, and it doesn't look like the fin. Good luck with that. So that was, and I think we're going to be done with that part before I get into the quasi-glassing part. So any other questions on that aspect of construction? Like that, you said the other one was open.
Oh, it's like Baltimore.
Okay, now quasi-glassing is my term for a method of fiberglassing without doing the aggravating parts. I don't know, guy, who was here has fiberglassed a rocket tube? Was it fun? No. Was it messy?
Yes.
Yeah.
What did you do about the seam?
Socks.
I use socks.
Use socks. Okay, everybody says use socks. Now I guess you can buy them from Quantum Leap.
Yeah, they work good.
Yeah, those work good. You can also buy it at Lowe's. This is a drain sleeve. It's $3 for 10 feet. This is a 4-inch. This will actually go over an 8-inch. I could actually go over an 8-inch tube without any problem. So you can stretch it out. Fits over. Very simple. Here's I'll pass this around. This was a cracked tube that I had just to make look so you can see what it looks like. I pulled this stuff over it and put what we call polyacrylic. Buy this at Home Depot or Lowe's. Lowe's loves me, man. And it's water-based. It's like a milky, it's very thin and runny, so it doesn't have globs of crap. And you just brush it on with a foam brush. And I've actually done that Alpha, I used this technique on the Alpha. I used a little bit bigger, but they also make a bigger version, like 6-inch, that'll fit over a 12-inch tube. And you stretch it over it, you put some tension on it, and then you brush this on and let it sit for a couple hours, and then you can just put on your fiberglass laminate, what they call just a finish coat, laminating epoxy to fill in the voids. So I will pass around this, and here's a tube. I also use pantyhose.
Yeah.
Pantyhose are great. They look at you funny when you buy them, the queen size in the store. So if you get past that hurdle,
It's not the size part.
yeah, maybe for you.
Are you trying them on?
No, Steve, your job is to model.
Yeah.
So I'll pass these around. This is a tube done in with pantyhose and the polyacrylic, and I think I put 1 coat of epoxy on it. This is a standard lock. What is it? About 6-inch tube, something like that. So I'll pass these around. And this was one that I put some spackling on it. That's kind of one thing you can use for filler. I use lightweight spackling. Get it at Lowe's. Automotive primer on top of that. It works pretty good. And here's another. This shows the same kind of thing. So I'll go ahead and you guys are going to juggle things, but.
Where do you get the laminating?
Laminating epoxy, you can get the epoxy at a marine store.
West Marine has one, for example.
Yeah. You can get Glue Products is a store where I live. They carry all kinds of cool crap. I go in there and I just spend money. You can also do. This is just. This is not an actual nose cone. I just got some foam at Michael's, not Lowe's, and pulled the pantyhose over that and brushed on the polyacrylic and a couple coats of epoxy, so you can see the potential for doing nose cones with it. So, and wings.
Actually, for fins, for example, by the way, when you're doing a built-up fin, you got to be careful on the leading edges because at high speeds you can get air in around the leading edges depending upon how you made your leading edge, and you can cause delaminations. So you also may want to consider some fiberglass on the leading edge.
Oh yeah, a little strip. You can get a strip. We call it like a tape. It doesn't shred little pieces out. But like here. I actually couldn't find it in my junk I had done. This is my before, and I had an after one that I already done. It came out pretty cool. But I'll show you how something like this you would do. Your wife can help you with the part of putting them on. We're better at taking them off. But you just pull it right over. without getting runs, hopefully. And now it does have a little toe on it, so you might not want to basically do that part. It's not a difficult thing. You would do a tube the same way. Okay, I probably could have done this before I came in here. I'm not going to be too carried away with it. So you get to where the toe is, and you can just kind of tie a knot in it.
I'd probably just use normal epoxy or resin.
And then you would pull it tight. You want to get as much of the seams and stuff out of it. And you can twist the other end. Make that tight. If I had a screwdriver, I could pop open this can of polyacrylic, but I don't have a screwdriver. But I'll go ahead and pass this around and you can see what it would look like. Ah, see? Man's prepared, man.
Hey Rick,
Swiss
when
will
you do
save
the
us.
pantyhose on these tubes like this,
Yep.
obviously you cut the slots after you do it.
After, yes.
Yes, have you ever had any problem with where the adherence wasn't
Nope.
strong enough that it wanted to come back off the tube?
Nope, once you put that polyacrylic on, it sticks pretty good. And then you put the epoxy on and it,
Did you prep the tube beforehand with a little light?
Light sanding.
500 sanding?
light sanding.
Why did you cut the slot after?
Go review it, Swiss.
It holds its form better if you wait until after you put it on. It stiffens it up and then it's easier. It's actually easier to cut that slot.
I guess if the slot goes all the way to the end, I've had tubes that were slotted, not at the end, but in the middle somewhere.
Oh, yeah, yeah.
No problem, fiberglass it, and then you can see where the slot is.
Right, that's how I do it. Yeah. I don't cut. If it's already pre-cut, yeah, you can, then you just cut out the area. But if it's a solid tube like this and I need to slot it, I'll wait till like you blast it and then I'll cut it with papers. So yeah, here's another tube that's got some finishing material on it, and here's what the wing would look like.
Yeah. Rick, have you ever tried on the pantyhose hitting it with a couple of coats of that heavy-duty automotive primer that has that's sandable and real thick?
Oh, like Bondo?
No, high-build primer.
Yeah. Oh, that. Yeah, that's good stuff. Yeah, anything to fill the weave, and then when you brush epoxy on it, you can get some orange peel effect, so you kind of got to be careful with making it too smooth. But this polyacrylic is very milky. It looks like milk. I'll walk down and you can see what it looks like. But it's very thin. So it's not like a thick epoxy material.
So it'll leave a lot of weave after you put it on.
Oh yeah, you're gonna see all the weave. It's almost
So you're just using that
That's why I
to
like
hold
it.
everything in place.
to adhere.
You brush that on.
It's water based, so it cleans up on water.
Makes composites.
Yeah, so I like water based.
So whenever you add fiberglass, like what he's doing, he's adding the
Polyacrylic. So, real quick, I'll just show you, it's a little messy, but not like fiberglass.
Do you have any problems with compatibility between the water-based and the epoxy, Rick?
No, there's no issues with that. Once this stuff dries, it's, you just dab it on like this. I don't want to do too much in here.
And you've never had it delaminate?
Never had that. And as you can see, the nose cone that's passing around, that's what it'll look like when it's dry, and then that's got the epoxy on it already. But the main thing is keeping the wrinkles out of it. And that's all you do, you just brush it on. Keep the wrinkles out, and then you just set that aside and let it dry. It takes a couple hours, and then you can glass it. So I'll just kind of leave that there, and it'll take a little while for that to dry up. And like my fingers on their cloth here. I'll just pass this stuff around and you can take a look at it. But, yeah, they used to stock this at Lowe's. Now I think you have to order it, but this is basically a sock. So the nice thing about doing this is, yeah, A, it cleans up the water, and B, it's not, you can do it inside. Your wife won't scream at you for stinking up the house. Well, she will, but not as much as if you were using something else. And basically, that's about it for doing quasi-glass. So you guys can take a look at the parts. Any questions on that? Yes?
What strength does the glass you do?
I actually measured the wing, I measured the deflection of the other one I had built like this. It was about 3 times less. With the nylon pantyhose on it and a couple coats of epoxy, I ended up with about 1/3 as much deflection. But I hung a weight on the end to see how much it would. So it does stiffen it up quite a bit. You can tell just the tube. A regular paper tube is going to be kind of easy to squish, and these are a lot more resistant to that. Right? So it's got a good strength to weight ratio, if I want to use rocket type terms. So, yeah, I mean, and the nice thing about it is, yeah, the stuff's fairly cheap, so you don't have to spend a huge amount of money. I think a can of this is like $12, and you know, whatever the other things are. And you can use, the nice thing, like the sonotubes that you get at Home Depot, which are a pain in the neck because they have that plastic goo on them, and I've just lightly sanded that, and it's also kind of rough, so you know, you tie up some of the ridges, but I pull that drain sleeve over it and epoxy it, and that's how we're doing an upscale gyrock. Hopefully we'll fly it this year. It's a 16:1 upscale of a gyrock. It's going to actually, you know what Estes gyrock is? It went up, kicked the motor out, the flaps deployed, and then auto rotated down. So our little group project that we've been working on for like 4 years, but it's going to do the exact same thing, but it's about 16 feet tall, something like that, 12-inch diameter. So it used that method on all the tubes.
Will it come down slow enough?
We're going to find out. It will deploy a cheat chute at 500 feet.
Okay.
But I built a 1/3 scale prototype, 4-inch diameter, and it worked fine.
Did you have the cheat sheet on the level?
I did, but it was coming out slow enough that it didn't really need it.
So it's just rear motor ejection.
Kick the can out and let the flaps do their thing. It's actually pretty cool to see it come down. Like, wow, that worked. First time. All right, so that's most of what I got for construction techniques on high powers. This is actually, I did this as an R&D project, but you know, there's a picture of what it looks like. That's a 12-inch diameter, 4-foot long PML tube. And on the right there, and I just grab that sock and knot it up either end, and then I just stand it on end, and I just brush down. It took me maybe an hour to sew it. Put the polyacrylic on that. Maybe used up probably a whole can of this for that.
How long does it take to dry?
Depends upon the humidity because it's water based, but a couple hours for that much. You know, that first coat. First coat kind of sticks in. Sometimes you have to go back and touch up a little bit, but. It will take, and then some of the epoxy, the first coat kind of soaks, and you use a lot more epoxy on that first coat, but the second and third coats, you don't use as much. And the epoxy cures up, and I let that sit overnight. The laminating epoxy, it'll sit 12, 15 hours. Yeah.
Why not just epoxy it instead of using
because if you just try to epoxy without using polyacrylic, it sags, and it's hard to keep it from getting wrinkles and bubbles in it. But if you adhere it down to the tube with this stuff, you don't have that problem. Yeah, I tried doing that before. I said, I don't want to be lazy. I'm gonna do this. Oh, well, that was a bad.
How did you come up with the idea?
I stole this from an AMA article about somebody had written in the AMA magazine about doing glider wings, foam glider wings. So that's where I got the original idea from. That's exactly what he was doing. He was taking a foam core and put the pantyhose over it. Nylon is very strong, has a lot of tensile strength to it. So it's a good use for this. And I said, oh, if it works for that, it should work for these other things. So yeah, it's very straightforward. So you can, you don't trying to lay up epoxy or fiberglass sheets on a round tube. It's just a chore. You got to either do a rotisserie thing or
Those socks work pretty good.
those socks work great, but they're kind of pricey. From what I remember right, they were charging a lot more than this is. This was like $5 for a 10-foot length of it.
They weren't that cheap, but they weren't outrageous.
Yeah, they were $5. Yeah. But this stuff I can go to the hardware store and buy. I don't have to work.
Didn't notice what the sides are made of.
I'm sorry?
What are the stocks made from? What material?
Oh, it's like a, it's a polyester material.
It is.
Yeah.
Got a lot of, it's designed for septic tank drain fields. So it's designed to take a lot of abuse and be resistant to tears from abrasion. So it's highly resistant to abrasion. I don't know what, it's not like a fiberglass. It's got more stretch to it than fiberglass.
Try to squeeze it, it's harder.
You ever worked with carbon fiber?
No, I've never worked with carbon fiber. I don't know how well that would work out.
It's overkill. Carbon fiber is overkill.
Unless you're going like Mach 3 or something.
Yeah,
you know.
for about 90% in Kevlar and stuff there, especially for talking just certification. Again, make it strong, but
But
don't
don't go
get
overboard.
carried away.
Yeah. Unless you've got money to burn, send me some.
Yeah.
Where do you get the large diameter paper base tube? Do you just buy that from a supplier?
I use sonotube. Lowe's.
How do you get constant diameter? Because
Well, yeah, they have it like, let's say this is a 12-inch sonotube, but it's like, some of it's 12 and a half, which is good because you can make couplers. I bring like a nose cone that's the size I want, and I go there, and they look at me funny because I'm walking through the store with this huge freaking nose cone. But I'll find a tube that fits, and then I'll get another tube that fits inside that for a coupler. So, and the sonotube's what, $10 for a 4-foot length, something like that? $8.
yeah, another source too. I go to local Ace Hardware.
Good old Ace Hardware.
Well, it's just a little bit more, but they can find.
That's true, yeah.
So you go and get us the dimension.
Yeah, you go to a hardware store like that, you tell them what you're looking for and why you need it, and you have to get you like you're off your rocker,
Yeah.
but if you can, yeah, I've got some.
Get a little sticker on the side.
Keep in
Russ
mind,
Joyner, by the way, I work with him at Pratt Whitney, so if you want to know anything about hypersonics, he's the guy. He can tell you all kinds of cool stories.
No, I can't.
Oh, well, he could, but then he'd have to kill you.
keep in mind that for any certification, you can use a kit. You don't have to build the rocket from scratch.
That's true.
Now, what we're going to look for is if you show up with a fin can or something on the rocket, we're going to say no. But for typical through-the-wall construction, I mean, there's nothing, you don't have to not complete it on yourself and fill it, but
Really?
kids are
Nobody
fun.
told me that. Some of us like the scratch build. I like the scratch build things. And then other people, they don't care. I'm not into the motor end of things. I'm into the vehicle end of things. Now, the other guys that are into motors, they don't want to spend time building the rocket. They want to stick a big motor in it and launch it. So there's nothing wrong with that. It's just, whatever floats your boat, and that's what we're here for. So, yeah. How much are the kits, like a level 3 kit? Do you know what they would go for?
You're going to push about like 3 bills.
Yeah, so I figured 300-400 if it's
The level
like
3,
a wild man. What do they call it? Ultimate wild man, something like that.
You didn't mention prices on level 3, but level 3, if you're working from scratch and you're buying it yourself, you'll tear up $1,000
Easily.
on a level 3 because even your basic M motor, a baby M, you're going to look at $250 to $300
Plus
just
the
for the
casing.
propellant load.
Plus the casing.
Plus casing. And the casing you can usually borrow from someone. You may be able to borrow your parachute. Ideally, you already own your electronics. But again, figure $1,000, and that's if you don't get carried away. Like I did, is have a sign painter put the sign name on the side and stuff like that.
That's one thing about this hobby. You can definitely get carried away with it.
What color?
Oh, okay. Well, I'm about done. So, any questions or yes?
Rick, have you documented how much strength this actually adds, like percentage-wise, or like?
No, that's like rocket science. I mean, I guess I could do some crush testing if I really did everything else to do, but it makes it stronger. There you go. It's strong enough to not fail. It also makes it a little easier to finish. By the time you put the epoxy on there, you can get a better finish on it. Yeah.
So Rick, with the rules and regs, what they are today, you're going for your level 3. How do you get the propellant to the site?
That is up to your level 3 to secure. It's like a level 2. You're supposed to, since you can't legally buy it, but yeah, you make arrangements to have a vendor bring the motor, and usually like I would tell our vendor, okay, Joe Blow's going to do his level 3. So he wants to use this type motor. Can you make sure you have that, you know, and give me the money and I'll order it plus 20% for my time.
That's something we're gonna need to plan in advance.
Yeah.
I will probably be there, there's Arizona also, so that's something we're gonna need to plan in advance.
Yeah, Megan, the logistics of a level 3 can be just as challenging as the actual build. And you know, I've had guys that had their level 3s and they get out there to fly and the field's not that good and the wind's blowing and they got go fever and I'm like, look, you know, there'll be another day. You don't have to fly it today, but be advised that okay, you might drift under the trees, and it's happened. And people are like, I should have listened to you. Well, I mean, we're not going to tell you what to do. We're just going to advise you whether, you know, we don't want to see people fail. We absolutely do not want to see anybody fail. We're not like your college professors. You know, it makes us look good when you have a good project. And, you know, and if you do fail, then we want you to learn something from it and improve it. You know, what's our rate? You know what the rate of success is for level 3?
If I had to make a swag, I'd say 75, 80%.
Yeah. And the bulk of the failures are?
Recovery.
Yes,
which Rick didn't go into when he was talking about shear pins and the like before. One of the most important things you can do is test your recovery system on the ground, because you need to size your charges to get the parachute out, you get experience packing. That's one of the things we're going to ask you before we sign off the recovery system is how did you verify that your recovery system is good? Now you'll hear there will be some comment if you want to fly the rocket as an L-powered level 2. That's one way of verifying the design. If you've got good ground testing and good documentation, and especially if it's a known kit, then that's another way of documenting the rocket. But that's what we're going to look at early on.
Make a recommendation on your level 3, what I did for my job, is just take your camera, videotape your ground test.
Yes.
Just send me ground test, mark down, you know, start at 3 grams, 3.5, 4, and then which one I picked at the end based upon, you know, the distance those comes from.
Right. But do your basic calculations of how much pressure you want. There's the formulas on there for how much black powder.
Yeah.
And start with that, test it. If you blow your rocket halfway across the county, back off.
That should be enough. On that alpha rocket,
Just about right.
people say, well, how much charge for that big, and it comes apart in the middle, so like a bulkhead in the middle. I use 35 millimeter film can filled with black powder. Those were my ejection charges. And people say, that's a lot of powder. I think, that's a lot of rocket, you know.
Yeah.
And it worked fine, you know. And could I have used less? Yeah, probably, but I'd rather have a little too much than not quite enough.
And one other lesson that just came up on our forum, on the L3 forum, is proof your black powder. Because we just had a case on the forum where someone had a bad lot of black powder, augured the rocket in, called the vendor and said, yeah, it happens once in a while. So,
because they designed that powder is sold for people that have antique firearms and things, you know. So if it chuffs, oh well, it chuffed. No, we don't want to chuff.
yeah. So
Chuff's
proof
bad.
your black powder. The other thing is that is think about your launch equipment. This is something I was guilty of when I did my L3 cert. My launch equipment was probably a little light for what I was doing. If you're launching a 40, 50-pound rocket and you've got to provide your own pad, make sure you got something that's going to support a 40, 50-pound rocket.
Logistics. Launch logistics are the afterthought. People don't even think, oh, I thought Joe So was going to bring his pad. Well, it's your project. You need to make sure that whatever you need is going to be on site. Any other questions? All right, well, thank you.